Hello and welcome to the Rally Point with Dominic Fielder, author of the King's German series, and myself, Rob McLaren, author of the Jobert series. And Dominic Fielder is not with us this evening. He's at the Torbay Air Show. But nevertheless, each month at the Rally Point, we catch up with friends who enjoy the Napoleonic period. Now, we record the first 30 minutes of the gathering, but once the recording is over, we remain online and the conversation continues. And this month, we would like to welcome Dr. Stephen Summerfield to the Rally Point. Stephen is a Napoleonic specialist and is based in Kent. Stephen, welcome. How are you this evening?
Very well. It's nice to actually have some nice weather for a change. Talking about artillery is always sort of difficult. You need to go through the sort of fundamentals. Now, again, you're talking about cannon, which is basically a tube, and a glorified air gun, in effect. The air is actually produced, or compressed air is produced by the burning of the gunpowder. We'll go through and talk about sort of the different types of gunpowder and so forth a bit later. So you've got here the evolution of the bombards, the cannon, etc. I mean, the most important one is, again, you're talking about serpentine gunpowder rather than a loose mix of the components and so forth, and hoping it will actually burn, which is always the problem. So again, you've got that evolution that's going on. You've then got the continental development in the 18th century, which is where artillery now, didn't have strange names for artillery pieces. Serpentine, bombard, great cannon, etc. You now had calibers of guns. So that's 3-pounder, 6-pounder, 12-pounder, 24-pounder, which is where the Prussians, the Austrians, the British, etc. adopted. Whereas the French and the Spanish and so forth used 4, 8, 12, 16, and 24. You'll see those differences in the Napoleonic period. The most important advance was the horizontal boring machine. We'll talk about that in a bit later. And in the mid 18th century, the most advanced artillery system was the Austrian. This was still superior to the Griebel system into the Napoleonic period in a lot of cases. It was lighter and more mobile than the Griebel system. The Griebel system had been produced to answer the problem that the French had, that their Valier system, their guns, were too heavy. So when they lost the battle, they would lose all their artillery. The Valier system was excellent for siege artillery because you didn't need to actually change the guns. You didn't need to do anything because they were the same as your siege guns. Then in 1757, you've got the Russian unicorns. French call them licorns, icons, etc. These were basically long howitzers, so making howitzers far more accurate. Then in 1759, you've got horse artillery introduced. Now, horse artillery, it's about mobile artillery. It's about being able to get the guns where you want them to do. It's not about really charging with the guns and so forth and using them as cavalry. In 1765, the Griebel system was designed. Again, we can go through the issues with that. There were so much problems of the Valier system versus the Griebel system, the blues and the reds, and how passionate the discourses were of that. But we can go on to that later. Now, production of guns. Again, there are two main types of guns. those that are made out of bronze and those that are made out of iron. At this period, iron guns were exclusively used in sieges and by the navies. They were heavy and they had real problems because they had a tendency of blowing up. And when they blew up, cast iron gave you very big, jagged bits. And unfortunately, the artillery crew didn't really survive. Bronze guns had the advantage that if you had a failure, they would deform. They wouldn't actually send great big shards and so forth sort of from that. Now you've got the real step change with Marit's horizontal boring machine meant that you cast solid. Why is casting solid so important? The problem you have if you cast around a core, you actually get oxide and different crystal structures and so forth, the weaknesses, etc. Which means with a core, you have to have much thicker walls. The thicker the walls, the heavier they are, the less mobile they are. It's again, a lot of this is about sort of like going, what can a horse pull? How many horses have you got? So you've got a trade-off. The solid casting and the horizontal boring machines came into Britain in about 1770. He was a Dutchman, and that was Schalk. Before horizontal boring machines, you can see here a vertical boring machine. And you can see how difficult it is to go and align and make sure you're actually boring absolutely vertically, etc. It's very difficult to do. Look at all the pulleys, look at all the ropes and everything else like that. This here would have been powered by horses. You can see in the bottom right-hand corner, the horses would have been moving round and round. This is the Maritz horizontal boring machine. And again, sort of like going, what you've got here is that you've got a drill. Now, what people don't really realize is that you're not moving the drill bit round, you're actually rotating the actual cannon. So that's the sort of difference. And again, sort of going, you're only talking about 8 RPM, something like that. So you can see how long these things would take. This is a Bavarian version of this, and you can see the horses powering this. And there's the drilling out from this. The British developments. You've got the horizontal boring machine at the Royal Brass Foundry by the wagons from Holland. The other important thing is just the part of the American War of Independence, the introduction of the block trail with iron axles and 5-foot wheels. Now, again, sort of going, those advantages and so forth really wouldn't be seen until the Revolutionary and the Napoleonic Wars, despite a small troop being sent to America, and they were successfully used in effect as battalion guns for the dragoons. Then in 1779, you may have heard of carronades. These were invented for the merchant navies, the ability to actually go and dissuade pirates and so forth at close range. But the Royal Navy realized that they were very useful, they were very light, and they could replace their 6-pounders and 9-pounders on the upper decks. The other part, which we'll be talking about soon, we'll be talking about cylinder gunpowder. And again, that is a great advance. Horse artillery in Britain it's again sort of going in 1793. It was when they got the royal patent in 1793. The Border Ordnance had been playing with horse artillery since the 1780s. Then we've got the story of the bronze 9-pounder and shrapnel. And then you've got the most important thing is, remember, the British were a little late to the party, and it wasn't until 1808 that you had a double draft, as in parallel horses rather than a single line of horses, used for their foot artillery. So their foot artillery was tremendously slow, which is the real problem you would have in the revolutionary period with the artillery. This is a plan drawn by a French spy, Dupin. And again, some of the best plans and information that we've got on the British arts of war and so forth was written by the French, because the British don't seem to be, or the officers, that interested in anything technical. And again, that's a note and a quote out of the Aide Memoire of Military Sciences, 1853, where a Royal Engineer grudgingly had to go and write about the artillery and the cannon and so forth, because he couldn't find any Royal Artillery officer willing to actually write anything. Black powder. This again, sort of like going, it is not a substance, it's an aggregate. So it's actually how you stick it together. It's not about what exactly is the proportions, because you can make some pretty good gunpowder without putting any sulfur in there. The only reason why you've got sulfur in there is it's lowering the ignition temperature. Again, sort of going, it's also about how good and how pure the different parts are. Because again, sort of going, saltpeter, especially if you produce by the niter system, which is the traditional system, you would have a lot of calcium magnesium nitrate, which have a tendency of being deliquescent, picking up water, which means that the actual gunpowder and so forth isn't as effective. It should be noted that you need about 1% water to actually have gunpowder to work properly. If it's totally dry and so forth, it doesn't work as well. But that's another side. The other thing to remember is that there are different grades of gunpowder. So it's exactly the same material, but it's actually how big the grains are. The larger the grain, the longer it takes to burn. So again, pistol powder is literally, so icing sugar, very, very fine and so forth. That will literally sort of like flash off. Whereas gunpowder is pea and bean sized. It's quite large lumps. And that would take a considerable amount of time. Now, you've got to remember that what you're wanting is the round should be accelerating as it goes out of the barrel, not decelerating. The problem is if you start using, say, pistol powder or musket powder in a cannon, you'll get a huge increase in pressure, and then probably the ball will actually decelerate by the time it comes out of the barrel. This is deflagration of gunpowder. It's quite interesting. So when I got rid of about 2 pounds of gunpowder at a reenactment and so forth, finding the longest pole I could find with a slow match on the end, and it went up, and I lost my eyebrows from it, and I was standing about 9 feet away. And the heat, I mean, you just can't. It's just incredible, the heat that sort of came off that. And you're only talking about 2 pounds of gunpowder. Gunpowder is non-explosive. It deflagrates, it burns. It only has, in effect, an explosive if you constrain it. that's where the issues over the size of the touch hole and windage, etc., comes into play, which I can talk about later. How guns works, as I started off, it's a glorified air gun. And it's again sort of like going for me being a chemist, it's again sort of going 12 grams, which is 1 mole of carbon, gives you 22.4 litres of gas. You can then suddenly see why you've got such a huge increase in pressure. Because if the ball isn't moving, where's it going? Well, it's going up here. So you're going to get a 20 to 30 foot plume of smoke. It may sort of burn, etc., but it'll blow the vent out and that. But again, sort of like going, the size of the touch hole is so important. The big touch hole, large touch hole, you get a large amount of reduction in pressure from here. This here is, of course, naval, where you've got a wad. The reason for a wad is simply sort of like to stop the ball from rolling down the barrel when the boat sort of rocks backwards and forwards. It would also be quite useful if you're firing downhill, which is a real problem in trying to actually depress a gun. This is the process. It's about process. It's not about what exactly the proportions are. We had great. The British had the fortune of the East India Company having the monopoly on good quality saltpeter. Most of Europe had to deal with salt beds, which is dealing with urine and nitrates, and then purifying and removing the magnesium and calcium. So from that, the charcoal is so important. You can't make gunpowder out of hardwood because it's not a sponge. Charcoal, in effect, is what you stick all the other components on. That's why you've got water, to actually stick these things on there, and then you dry it, and the drying process, and making sure the drying process doesn't cause dust, and the dust having dust explosions. Corning of the powder, that's the real difference between serpentine and corned powder. Corned powder is making those very uniform, large lumps. You would then screen that through a sieve to give you different grades. And because of the different grades, the different burning rates, and the different applications of those. And another thing that sort of people forget is sort of going, why we got Sicily, why the British had an army in Sicily. Well, that's where it was getting its sulfur from. We now come on to the great advances in sort of cylinder powder. People talk about the British having the best gunpowder in Europe. This was simply being able to cook your charcoal to remove the rosins and the moisture, etc. So you're able to actually get a very, very clean gunpowder that would actually stick on there, and it would be about 25% more powerful. That is great, except if you're on the Royal Navy when the cylinder powder blew up most of the artillery pieces for the Royal Navy. So the Royal Navy was having real problems in the revolutionary period, trying to find enough guns to go and fight the French. So there's pros and cons sort of from this. So you've got a purer gunpowder, so it burns faster, it burns more uniformly. And because it burns much better, you can use less. This is why you're talking about a quarter charge rather than a third charge used by the French. In logistic terms, you're not having to move as much gunpowder as you would need if you're talking about third charge. The other thing is that you're not heating up the gun. The problem is that you're talking about a huge amount of pressure, huge amount of gas that's being produced, and then you've got the problems of heating the gun. Heating the gun has difficulties depending upon whether you're going to cast iron or a bronze gun. The problem with the bronze gun, if you fire too quickly and too often, you have muzzle droop. It'll actually soften. So accuracy is a problem. This also meant that because it burnt quicker, it burnt more efficiently, you could have shorter cannon. Shorter cannon means that they're lighter. Lighter means less horses, and Britain never had enough horses. So, I mean, that's a logistic win. Right, we come to different types of artillery. Field artillery is what I'm going to be looking at for this this presentation, and I will be looking at the heavier guns probably in a future one. But there are three different types. There's foot artillery, horse artillery, and mountain artillery. We won't be talking too much about mountain artillery. That's another absolutely fascinating area to discuss. This is a cannon, again, sort of like going, you've got a cascabel, a button. That, again, sort of going, that is where you would use to help lifting and moving a gun. You would strap a rope round here and the trunnions, and you would be able to actually hoist it up from that. As you can see, you've got no dolphins in here or handles. These are reinforcements, and again, this is still quite an early 18th century gun, so you've got a lot of reinforcements. You come to a later pattern, more modern gun that is completely clean because it was realized it wasn't required. This is the vent field, and again, that's important that you can actually rebush your gun, which means you can actually put a new vent in the gun. This is where we come on to sizes and difference in sizes. This is why you couldn't use French ammunition in a British gun, or vice versa. In a British gun, it physically wouldn't fit. In a French gun, it would rattle so much that it's not going to hit very much. So it's again sort of going, just having an idea, but also remember that you've got here, this is 3 inches, 76 mil, and that is again sort of going not that much smaller than 120 mil, which is a 12-pounder. So again, the sizes of the ball is an important thing to sort of consider. And I've got some cannonball and so forth I can show sort of later on if people are interested. Right, the Greenville system. It was a great design for static warfare. It was the solution the French needed in the 7 Years' War. Remember that people design cannon or equipment and so forth to fight the previous war. Really, the last war the French really were heavily involved in was the 7 Years' War. They were involved in the American War of Independence, but to a lesser extent. The British learnt a huge amount and the requirements of making mobile artillery. it's interesting that the Grievable system was first introduced to Spain rather than France. And it was finally introduced in 1777, 1778. Now, what they say about the Grievable system is always amazing. When you're talking about going a rationalized system, is it rational to have 22 to 28 different wheels? Now, the reason why I've got 22 to 28 is that every time I count them, I get a slightly different number of wheels. And it depends what you're counting and various things like that. But again, sort of going, all the reason for the different size of the wheels is because it was based upon caliber size, not upon a rational thing of going, well, a 5-foot wheel will do for all those three pieces. Well, the reason why I've got the different size wheels is that they are all built upon X number of calibers of your gun. So that's again sort of going, that's an 18th, 17th and 18th century method of measuring, of designing pieces. The 8-pounder, again sort of going, people, how wonderful they are and how effective they are in on the battlefield, etc. The difficulty you had with these is that they've got two trunnion positions. The barrel was too long to go cross-country pulled by horses. We know this because I've broken a cannon, a 12-pounder, which is similar sort of design to this, going cross-country, where the barrel was actually wobbling up and down, hit the ground, broke the cap squares, which are these, broke the wheel, spokes of the wheel, and almost turned over. We were only going at barely a strong walk. This was where we thought we could actually move without having to move it back to the traveling position here. That was a very, very expensive mistake. The other part here is the ammunition was carried on between the cheeks here, but you're only talking about 8 rounds of ready ammunition. The rest were carried in a caisson. This is a slightly better designed gun, but it's only a 4-pounder. Again, sort of going, that really was designed for battalion or regimental artillery. It wasn't devised for anything else. Now, it's amazing that people seem to sort of ignore Napoleon's words and condemnation of the Grievable system. Especially the Americans, they're sort of going how wonderful the Grievable system was, etc. So Napoleon basically saying is sort of going, well, we shouldn't have 4 and 8-pounders. And that is simply sort of going, we've got an 8-pounder where a 4-pounder will do, or vice versa, and there's a problem there. It's again sort of going that none of the artillery officers seem to know when to actually use an 8-pounder or a 4-pounder. So a single caliber was therefore more efficient. Hence, we've got a 6-pounder is used for the Napoleonic period. The 8-pounder were removed from in about 1809. They produced enough of the Year 11 system. So by 1809, there were, or just after 1809, there was practically no 8-pounders in the French army. Somebody comes back to me and says, sort of going, well, what about the Peninsula? Well, that's because remember earlier I was talking about the Spanish use the same calibers and actually use the same system, the Grievable system. So the Spanish had huge stocks of 4 and 8-pounder ammunition, and they had some very, very good guns. So a lot of the guns that the French used during the peninsula weren't actually French, they were probably Spanish. The Year 11 system, a far better system. You're talking about, look here, there's no astragals, there's no reinforcements and so forth. It's making it quicker and easier to make a gun because it's just a simple tube. They'd learned and understood that there was sufficient metal so it wouldn't rupture. So you weren't needing these bands around them. This was introduced in about, it's a Year 11 system, so that's 1803. Really, they started production in 1805. Interestingly, the earliest uses of the Year 11 system was actually by Kingdom of Italy. And even the Kingdom of Naples had more Year 11 systems than the French. Now, this is a very interesting table. And again, sort of like you're talking about accuracy. This is really sort of showing that a Greenville 8 and 12 pounder at about a kilometre might be able to hit a barn. Probably not at the barn door. But you're talking about 500 metres. Look, it's 1.9 metres, almost 2 metres, and it's about half a metre for a 6 pounder. This is the Year 11. So you can see how much better the Year 11 6 pounder was. Unfortunately, this is not taken into any account and so for in the war games rules, because of course an 8 pounder is actually a pretty good weapon in war games rules compared to a 6 pounder. Yet a 6 pounder could fire faster, it was more accurate, it was a far better piece of artillery. There was no Grievable guns present at Waterloo, except a few 12 pounders. Even the howitzers weren't actually Grievable. They were a copy of the Prussian 10 pounder cannon, so they were actually a longer howitzer. The stubby little howitzer produced by Grievable was barely a mortar. Very inaccurate. But again, I've got other tables, probably another time. I thought people would want to look at and glory at the beauty of the gun tubes here. This again is Borodino Museum. This was cast at Strasbourg. And again, sort of going, look at the beautiful chasing on the barrel. This is the number of the gun. And again, most French guns actually had a name for them. This is the Fly. The 1808 system, it's basically a cobbled together. French, as ever, was running out of money. They had huge stocks of stuff. The 8 pounders were being removed from being used. So they took off all the ironwork and put them onto Year 11 woodwork. So hence we have titled it the 1808 system. It's a halfway house. As you can see, you've got handles here, where this is the original Year 11 system. You've still got this turned up rear, which made it easier to pull along, to bricole, as well as pull behind a horse and so forth as a prolong. So it's again sort of going, it is a superior system. The Limber actually had an ammunition box, which was a great improvement. But again, the problem is that the individual ammunition was still in cells. It was still an 18th century solution. French howitzers, as I said, this is the Grievable, and you can see that it's stubby. It looks more like a mortar. This is the longer 10-pounder copy of the Prussian. This is a longer howitzer, far more accurate, and this is what would accompany 12-pounder batteries in the main. The great advantage of the 24-pounder howitzer of the year 11 is the amount of ammunition that you could actually have, because it was a 5.5-inch or 5.5 pouce, which is about 5.9 inch in imperial, etc., rather than a 6 pouce. And you could actually have the same amount of ammunition in 2 caissons rather than 3 caissons, which you would need for a Gruber howitzer. Mobility. Now, this is again sort of going. This is really sort of like taking a simplistic approach. This is dividing the weight of the system by the number of horses. I understand very well that the first 2 horses have more pulling power than the next pair of horses and the next pair of horses. So it's approximately 50% the 3rd and 4th horse, and a quarter in the 5th and 6th horse, etc. But again, sort of going, I can go through the calculations if somebody's that minded, and there's calculations produced in the manuals. So what's very interesting is, of course, the most mobile artillery is the Austrian. This would probably, this again, that is without having the riders on the trails and so forth. But even so, that would drop it down to this weight here. So only the French 4-pounder was comparable and mobile. You can see the great improvement the year 11 system. You've still got sustained fast trot. So this means that you can actually do grand tactical movements of your artillery on a battlefield at a fast trot. The problem you've got if you're down into the sustained slow trot means that you could do some dashes, but you're not going to go very far. You've also got the problems that you've got the 8-pounder having to move the trunnions position and so forth, and trying to actually deploy. Again, sort of going, people have forgotten about the Royal Horse Artillery had a light 12-pounder. That wasn't really used on the continent because of the problems that you talked about, 12-pounder ammunition, and it's just the sheer problems of more horses you're requiring to pull the ammunition and that. And often missed in the Royal Armouries at Fort Nelson, which is identified previously as a 6-pounder, it's actually a 12-pounder, light 12-pounder that's on display. Again, we can talk about different types of mounting of artillery. You can talk about fully horse-mounted artillery compared to vehicle-mounted artillery, compared to semi-vehicle mounted artillery. The Austrians had vehicle-mounted artillery. This had the great advantage that you didn't have to train a gunner to ride a horse. This isn't easy, trying to actually sort of train a gunner to ride a horse. For the French, they followed 2 different systems. One was true horse artillery, following the Prussian system, which was mainly sort of 4-pounders, and a Wurst system, which is vehicle mounted. So you're still seeing very mixed artillery batteries for the French, and even horse artillery was 12-pounders. Calling it horse artillery when it could barely sort of walk around. It's again sort of going, that's the gunners rather than how it was operated. So you can see here the great advantage of going to the Year 11 system. You've now got a mobile horse artillery with a reasonable hitting power. It wasn't quite as mobile as the British, and the British had a great advantage, which we can go and talk about, with their block trail system. So we've talked about the problems with 8-pounder. Really, it was unsuitable, if I could spell, for horse artillery. Mobility of foot artillery, and again, the French really are suffering with their mobility of their guns, because they were very long, very heavy, and the construction of their wheels and carriages and so forth meant they were about 1.5 times the weight of other people's. Also, the type of wood they were using. Again, the Austrians, it looked more massive, but again, they were using pine rather than oak, cheeks, etc. The block trail system. I know it's rather embarrassing being an Englishman and saying that this was the best artillery system during the Napoleonic period. Now, if you look at this and you go, well, we haven't gone much far away from that into Ukraine today. We still have got, in effect, a block trail system, as in how you pull the guns. I know they then split, and so for the trails and so forth, but it's again sort of going how they are attached to the vehicle. You've also got a lower center of gravity, center of where the piece is actually attached. You're less likely to actually flip over rather than the high end with the spike, which again we can probably look at again another time. The other great advantage is that you're talking about a 5-foot wheel, and the 5-foot wheel was on the limber as well as the ammunition wagon, which means when you break one, you can go and nick one off another vehicle. You couldn't do that. You didn't have that ability to actually change wheels to that great extent with the Greenville system. And the other wonderful advantage is ammunition boxes. Rather than individual cells, you had ammunition boxes, which meant resupply was a lot quicker, a lot safer to do. The ammunition was actually drier, etc. And also remember that the French copied the block trail system in 1826. So it can't have been that bad. And then the rest of Europe. Remember, the US came to Europe wanting to copy the Greenville system, and Mordecai went back to US with the block trail system, which is a modified version of the French. The difference you can see with the French and the US is the number of spokes. If it's got 14 spokes, it's French or US. If it's got 12 spokes, it's British. We're now talking about the ammunition. We're really just going to be focusing upon the 6, 9, 12 pounder here. This here has got a sabot. A sabot is very important because that's what the ball was strapped to, and the ammunition, the gunpowder bag was strapped to this. That is called fixed ammunition if you've got all three elements. Semi-fixed ammunition is that you've got ball, sabot, and a separate gunpowder bag. The importance of a sabot is that it made the more reliable the build-up of pressure. This was literally a stopper. that would only move after you've got about 1,000 atmospheres. So it would actually propel the ball out of the tube. It would also get round the issues over windage, etc. As you can see here, here's a strapped 12-pounder and to a sabot. I always find this quite interesting, sort of going, you don't have to be hit by a cannonball. You can just be hit by the shock wave of the ball punching through the air. So this is an example of that occurring, where a person died and there was not a single wound on the person's body. Howitzers are very important. They are completely ignored by wargamers, and they're very important, especially if you're wanting to burn down buildings using carcass. They've got probably twice the amount of canister balls in there, so they're very useful for defending your position, your artillery position, and your ability to actually fire over a hill, into a wood, etc. Shells, these are simply hollow balls with a fuse. The fuse was a piece of wood, and that would be cut to give you the approximate flight time. Remember that if you're at about 3/4 range, that would be a flight time of about 24 seconds. So you're talking about something that's moving very slowly. Ball's Troop, Royal Horse Artillery. Again, this is an interesting sort of area. This is first recorded indirect fire at the start of a battle. This is where the battery commander, Ball, could not observe the fall of shot. So he used Ramsey, the battery commander, next to actually call out fall of shot. It was a very difficult thing for him to do. This was firing over Hougoumont into the wood where the French were coming through. So you've got the difficulties of range. The range was between 3/4 to maximum range. So the error in the ranges could be plus or minus about 100 yards. And remember, you've got a slow moving object, and wind could actually affect it quite considerably. But again, sort of going for those cricketers and so forth, you think about trying to actually work out where a ball's going to go in a strong wind, and trying to actually catch a cricket ball that's moving all over the place. The spherical case, it's again sort of going, this was actually needing to cut the fuse to the correct length and to make sure how it would actually then disperse. In most cases, we were actually yorking. The idea was to, in effect, york which is a cricketing term, the opponent as they're coming forward. Spherical case was was very good when you had a fully surveyed battlefield. And of course, at Waterloo, the Royal Artillery surveyed the battlefield and knew exactly what the ranges were, etc. In an encounter battle, spherical case becomes problematic, like shell is, because it's all about estimating ranges and deciding about what the range is and cutting your fuse. Remember, the person that was paid the most was the bombardier, and the bombardier was the person in charge of the howitzers. Spherical case was not fully developed. it had the problem that you had gunpowder and iron balls, and they could actually make the thing go bang when you didn't want it to. So you had different improvements of separating the gunpowder charge from the balls. And then you've got the spherical case shot by Boxer and the diaphragm, which is later, which is even post Crimean War. Canister. It's again sort of going, this is where we get the use of tin cans. Remember, the French invented sterilization and the canning system, but they put them in champagne bottles. The British went, we don't have champagne bottles and we're not going to buy them off the French. We've been making canister, so we'll go and put them in there. It was about 30 years later that somebody actually invented the can opener. So the only way of opening a can was to hit it with a chisel and a mallet and so forth and hope you get in there. You can see here the different numbers of balls and the sizes and so forth that were used by the British. This again was fixed ammunition. As you can see, that the bottom half here is where the powder charge was. The next line up here is where the sabot was, and sitting on top was the canister. How exactly the canister ruptured and so forth is still something that I would love to actually see some proper testing from this. These were lead soldered, and there's a tremendous amount of heat, so they may well have actually opened up rather than ruptured. It's not exactly the same as firing a shotgun, and it has not quite as effective pattern because it's a bit variable. So sometimes the canister would actually open up, fly out very nicely and open up at a close range, and sometimes it would hit the opponent on the fall and not actually open, and would only open when it hit the ground. Grape shot were only used, and again people use the word grape. That really is not, that's heavy canister. You would not use iron balls in a bronze gun if you want to fire the bronze gun more than 2 or 3 times, because the balls are going to make dents in the actual gun tube. Carcass, the reason why I've got it here is sort of going, this is how you set a light Hougoumont. Why the French didn't use carcass and didn't set a light Hougoumont, I don't know. This is again sort of like going, you've got 3 fuses, and the idea that at least one of the fuses and so forth is going to burn. You've got inside there a material that will burn probably to 8 to 10, 12 seconds. Ammunition supply. Again, sort of going, this is an important area, and probably I should take much more time on this, and we can always go and revert to this. The British used ammunition boxes on a universal limber and caisson. It was swift to resupply. Also, it had 5-foot wheels, which mean it could go anywhere the guns could go. And it was an articulated vehicle, etc. It was short. The center of gravity and so forth was lower than that of a caisson. The caisson is more like an articulated lorry going cross country. And you think about trying to go cross country at about 20 miles an hour on an articulated lorry. I really would like to see how long that would last, it not falling over, etc. The French, just about everybody else, used ammunition cells. which meant every single round had to be manhandled. The French caissons notoriously leaked, which was a problem for their ammunition. You had a very, very small front wheel for the limber and the caisson, which meant that you only got a 3 foot, 3'6" wheel, which meant that it would bog down so easily. The statement that the battle can't start because I can't move the guns was I can't move the ammunition. It wasn't the guns. They could get the guns to where they needed to. If they needed to, they could pull them. What they couldn't do was get the ammunition caissons anywhere near. You also had the difficulties that each caliber had its own divisions, which meant each had to be built for each different ammunition type. So as you can see, everybody followed the British in the Victorian period, First World War, even to modern day, the type style of the artillery system. French logistics, just simply counting the number of calibers. This is a good period. They only had a few, 10 calibers, 15 different carriages and wheels. The French, 1809, 19 calibers, 28 different carriages and wheels. And it got even worse in 1812. Now, the reason why I start talking about sort of like the nightmare is that look at the shot weight. As you can see, very few of them you can use the same ammunition. So you've got a real problem in sort of like trying to actually resupply, and then you've got the different sizes of ammunition cases, etc. The British, at the start of the Peninsular War, they basically had the 6-pounder and a 5.5-inch howitzer. A little later, gradually introduced was the 9-pounder. The 9-pounder was a response to the French using 8-pounders, wanting to overmatch them. It was also the Border Ordnance had a huge amount of 9-pounder ammunition left over from the Royal Navy, and the Royal Navy didn't want to use it because it had replaced the 9-pounders from the upper decks of its ships with carronades. The horse artillery kept to the 6-pounder and the light 5.5-inch howitzer until just before Waterloo. It's again sort of like going, I love these quotes from Frederick the Great. Augment your artillery, without which you will have no success in your enterprise. Artillery adds dignity to would be otherwise an ugly brawl. I think that says much about the artillery. Again, we can go in more detail, and I'll be interested in your questions. Thank you.
Stephen, that was a fantastic presentation. Thank you very much. It highlights a great deal. Okay, thank you, everyone. Fascinating conversation so far. I am about to end our recording, but please stay online as we continue the chat. To wrap up this month's Rally Point, thank you, Dr. Stephen Summerfield, for joining us. Thank you, Stephen.
Thank you.
For those of you who have joined us live this evening, thank you for your time. Next time, why not join us here at the Rally Point next month, when we hope to catch up with Mark Middleton for a day in the life of a French infantryman. Simply contact Dominic and I for your Zoom invite, and our details are at the end of the video. And share Rally Points with your friends so we can hear from them as well. Any previous Rally Point chats are up on our YouTube channel. And so if you've enjoyed this Rally Point, please leave a quick review. So it's good morning from me. And if Dominic Fielder wasn't at the Torbay Air Show, it would be good night from him. Good night.